Hi, I'm an old guy and I do maths. One of the things that people have a lot of trouble getting their heads around is the idea of rates of change. Now, this pertains to differentiation and other areas of calculus as well, but the first time you strike it is in the introduction to differentiation. So, what I'm going to try and do is take a couple of examples, badly sketched out, and show the graphs of the rate of change of a fluid level in each of these. Okay, so basic introduction. What we've got here is we've got a container with straight sides and 2 litres of fluid in it. Here we have a container with sides that look like something that you might find in a chemistry lab, and it also has 2 litres of fluid in it. So the starting points, if we are to fill these to their brim, to their capacity, which is 10 litres for both, the starting point is 2 litres. It doesn't have to be, but it's useful for me to have some fluid in here so that you can see how that is interpreted on a graph. Okay, now the rest of the story goes that liquid will be poured into each of these at the same rate. That's important. So whether it's 1 litre per 10 seconds or whatever it is, liquid is going to be poured into both of these at the same rate. And what you're hopefully instinctively going to realize is that the liquid in this is going to rise at a constant rate because the sides are the same distance apart all the way up. And even though the liquid will be poured into this at a constant rate, which is the same as this, what's going to happen is that as the liquid moves up the sides here, you're going to hopefully notice that the speed at which it moves up the side increases. And it reaches this point, and then the speed at which it moves up here will be constant. It'll be different to this, but it will be constant. Okay, so I hope that I've made all of that clear. So let's see how this gets graphed. Okay, right. So this is the graph of our beaker with a little bit of fluid in the bottom, 2 litres of fluid in the bottom. And what you can see is that at time 0, there's 2 litres in the bottom of this. And at some later time moving across the x-axis, there will be 10 litres in this. I should move the graph up to here. So that's 10 litres there. Okay, and this will fill at a constant rate. And we can graph that this way, a linear graph. This is a graph of a constant rate of change. The rate of change in the liquid in this beaker with respect to time. So at time 0 there were 2 litres, at some indeterminate time in the future there are 10 litres. And we can plot those coordinates if we need to. We've got these coordinates here. We can work out the gradient of this, and that is the rate of change. Now, we move across to this, and just as a reminder, I'll do a rough sketch of what we're looking at here. And we've got some fluid in the bottom of this as well. 2 litres. We start at the same point. And what happens as we pour liquid into this at a constant rate, the same rate as we did with this, the speed at which the fluid moves up the sides of this container increases. it's much slower down here, it's faster up here. And we can see that reflected in the curve of this graph. This is a graph of a rate of change that is always changing. We can find it at a certain point using calculus, as you will see. And then what happens is, at this point, we notice a change. This is no longer curved because these sides are straight, and the liquid is going to be poured in here at a constant rate, the same rate as it was poured in here, and it will move up here at a constant rate. It will move up here faster than it did here, and that's reflected in the slope of the straight part of this graph at this point. Now, those are the basics of how we graph and explain a rate of change. It can be a lot to get your head around. If you're doing this in school, I think that these will be familiar examples, so I hope that this has been helpful. Thanks very much for watching. See you next time.